Good afternoon, everyone. Uluru, Central Australia, Alice Springs, desert area. A single day, a single year of rainfall. Setting waterfalls cascading down the cliffs. Now looking at the erosion patterns on the face of Uluru, you need to ask yourself on the far right side, if this is the type of waterfalls coming down, what scale of water needs to come down to caveat that type of erosion pattern out of there? Bureau of Meteorology would have you believe it's a one-time event from a compressed weather pattern pushing down from Indonesia. But as we look over the year 2015, 5 times wetter, breaking all records back 116 years. Which quickly reminded me of the Sphinx. They found on the south wall rain erosion patterns. And we know our climate's always changing. It's going from mini ice age into warming periods and then back again. With these fluxes come rainfall variations. Every grand solar minimum, Egypt dries out, grand famines through history, and in the inverse, Australia seems to get wetter. Overlaying the two, and knowing that we're going into a grand solar minimum right now, here's your forecast for 2 different places across the planet. And please remember to subscribe to Adapt 2030. Uluru, near Alice Springs in the desert area, Central Australia, known for its dry conditions, right in the center of the Christmas holiday, 232 millimeters of rain. That's a new record. A bit wider out here for you to see. When we take a look at the climate data, usually for an entire year it's 274 millimeters. Yet what the BOM forgot to tell you is on December 25th, they accrued another 111. So when we add that, it's well over 300, breaking all-time records for rainfall in this area. The records extend back to the 1850s. Some amazing images coming off social media here. And I will ask you on the bottom left corner, how much higher does that water have to be to start to erode at the high water mark there, compared to this record flood? Waterfalls cascading down Uluru, rare sight indeed, made international media across this planet. And again, I'll draw your attention over to the top right corner. You can see the waterfalls coming down, but what type of ferocious water would need to be continually coming down to sculpt out this sandstone to the depth and width that you see there? Close-up image here of exactly what I'm talking about. Aerial view of Uluru. Yellow asterisk is where I pointed out the waterfalls with a deep sculpting, visible even from this height. Severe thunderstorm warnings, flash flooding, all types of unusual incidents coming through at this time. And then on Christmas night alone, the BOM labels it as a once in a 50-year event with 61 millimeters falling. But when we look, far right December mean monthly rainfall average is only 20 millimeters. That was 3 times the monthly total in a single hour. Definitely some flash floods going on. Several people disappeared, got swept away in the streams. Every face of this is dripping with waterfalls. Cloud cover on the peak there. What a rare sight. And then more weather warnings coming on December 27th. More flood warnings. Pushing up into another 100 millimeters of rain. Then looking over the cold front, slamming South Australia, that center area right there that you can see the storm passed over. Then continuing on for the forecast, another cyclone, Southern Ocean coming up. December 30th, more rainfall for that same area in Alice Springs. I did call down to the Bureau of Meteorology and spoke to one of their field offices down there. They told me it's a one-off event because of the way there's compression and the different airflows from Indonesia pulling things down through the central desert areas. Yet when we look at the yearly total, across Australia it's pushing 5 times more rain in that purple. That's not a one-off. That's a breaking records as far back as they go with the highest rainfalls they've ever experienced. Now, if you follow the river basins out of Alice Springs, you're going to come into the Simpson Desert. That place is going to bloom a once in 150-year bloom. So if you have a chance, get out there, take a few photos. I'd love for you to send me those. If you do have a chance, I'd be so grateful if I could see these amazing flowers gifted to us just once every couple hundred years. This is truly a multi-generational event. Now, we do know climate ebbs and flows. We go from cold to warm to cold again. Australia, New Zealand is that dark arrow pointed directly to where you can see the changes have come with the temperature variances. This is over all the continents on our planet mapped out so you can see how long it was cold, which place was more severe in the intensity compared to the northern or southern hemispheres. You'll see this every time that you look through history, not this 30 or 40 years of satellite data or 150 years of data that says it's increased 1.5 C in the last 150 years or 0.4 C over the last 30 years. They give you such short time frames to judge anything on in the climate debate. Let's go back a couple thousand years and take a look how much variance there is. This is in the Alps and the Altai Mountains. Tree ring data reconstruction, always changing. When we look at tree ring densities across the northern hemisphere in the boreal forest, we see the same thing again and again. Wherever they go and measure, whether it's stalactites, tree ring data, lake core sediments, offshore ocean sediments, ice cores, whatever it is, we see this variance through our climate. Now, can we predict what's going to happen based on the past? Aboriginal elders point out where they used to be and where the climate for the Aboriginals was more hospitable than it is today. I know the relocations happened. That's quite a bit different than the natural variance when somebody would have to leave because the area got too dry. But this was the original. Before the relocations came, they were pushing this far in where it was much more hospitable than it is today. They have different ways to differentiate clouds. Especially in the desert, this would be one of the most important survival mechanisms you could have to know what types of clouds are coming. Taking a look at the map here, this is going to do some reconstruction back through history of rainfall patterns. We're going to focus on 1, 2, and 4. Ningbing Range, Kimberley region, oxygen 18 isotopes, the higher, more rainfall. So I circled in yellow the outliers there where it was extreme rainfall. And I'll bring you back to about 1,000 years before present. Extremely low rainfall, but within just a couple decades it shot up. We were told recently CO2 causes this, but here's another example of natural variability. So when you come to the far left, it's continuing to increase in rainfall. That number needs to come up. Area where the asterisk, it's exactly where this area is. This is the new cloud funnel, and this is where the new troughs in the jet stream are pulling this moisture down. And I could see easily how this is getting pulled right through central Australia. These areas are going to start to get wetter in there. There's going to be more plant cover, which was another measurement, is the pollen, to look back in history to see how much pollen is actually in the sediments. Taking a look at the swamps, this is northeastern Queensland. Everywhere you see a circle is a grand solar minimum matched with the scientific astrophysics with the rainfall patterns over Australia. They match up really well. When there's a grand solar minimum, it's going to get wetter in northern Queensland, especially around Darwin. And when we look at these last few years, that dark blue, most rainfall ever, is 2010. The red is this year. So what are the chances in the last 5 years that there's been 2 of the most recorded rainfalls in the last 160 years? In Lake Callabona, that's that central area, south and east of Alice Springs. I circled in the yellow. Exceptionally heavy rainfalls during this, outliers of lake filling, which means exceptional rains in that central area draining off. Currently, this thing doesn't even have any water. It's a salt pan desert. I bet after this rainfall, water is going to start filling back into that basin again. And then we find again anomalous rains in 2010, right in the same central area. It's a trend, it's a pattern, it's increasing rainfall. Now when we jump over to Africa, During the height of the Ice Age, northern Africa was a desert. Come back around 9,000 years ago, huge changes. We get into Mediterranean forests, scrub, grassland. And then 7,000 years ago, we are definitely into habitable rainfall completely across the Middle Eastern regions, all the way from Saudi Arabia, clear over to Morocco, rain, 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 grasslands. Which brings me to the point here of the Sphinx, and the water erosion on the Sphinx, which was very similar to the water erosion in Uluru. The Sphinx had been buried for millennia, looking exactly like this when Napoleon and their crew went down and found it when they did the first excavations. There's no way erosion could have taken place on this, buried at that depth on the interior enclosure walls. Now, after all the excavation, nobody had even noticed until John Anthony West went down with shocked, and they noticed that water erosion was on the south wall of the Sphinx enclosure. They all said water erosion. So when was the last time that it was consistent rainfall? And when we do look back into the grand solar minimums, every single time there's a grand solar minimum, there are Egyptian famines. The Nile River flood maximums are decreased, and they receive little to no rainfall during these times. And if you look where those red asterisks are that I put there, and match them up with the times across the last 1,000 years of grand solar minimums, you're going to find an exact match going down the backside into the decrease, into the bottom of the grand solar minimum, into the trough. So I was thinking, if we are going into a grand solar minimum, this should match up where the rainfall should be decreasing across Egypt. And here we are, the spatial temporal variability of rainfall in the Nile Basin. Decreasing since the 1920s, starting to match the pattern again. And Australia should start to increase in precipitation. So I overlaid the two here and we go. So here's a forecast correlating and overlapping these two data sets in two different places across the planet. So these two will be proxy areas for each other. The wetter areas in Australia, the inverse, the drier area across the Nile Basin. Thanks for watching. Hope you got something out of the video, a little bit of history.